February March 2023, paper 5, variant 2. Question 1. So this question is about the reaction between the iron 2 and silver ion. After they react, so they will form the iron 3 and the silver, and it will form equilibriums after that. So the Kc we can calculate it using the concentration of the iron 3 and the iron 2 and silver ion. The silver particles that form is the constant, so we normally don't put the solid into the Kc. Okay, so we in this question we have a few steps, about 8 steps. So to make it fast, so I will just discuss using this diagram. Okay, so first, in order to start the reaction, we need to put the silver nitrate solution and the iron 2 nitrate solution. So we put 100 cm³ each to a conical flask. So let them mix, and we label this conical flask as flask A. After that, put the stopper and shake it, put it for a few hours, about 4 hours. After that, shake it once a while. So let them react. After that, let this flask A to stay or to settle for 1 hour. So means after the 4-hour shaking, so the shaking is not continuously 4 hours, it's just once a while for 4 hours. After that, let the mixture to settle for 1 hour. Okay, so once it's reached equilibrium and the silver solid settle, so we're going to pipette 25 cm³ from the flask A to another flask. And this new flask, we just label it as flask B. So in the to the flask B, we need to put the sodium chloride solution, 5 cm³, 1 mole per dm³. And after that, we need to add 20 cm³, 1 mole per dm³ H2SO4. Okay, so after we add the NaCl, so we will see the white precipitate, because silver ions that in the equilibrium, or silver ions that inside the solution, it will form precipitate with the chloride. And after that, okay, after we add acid, we can use this solution for the titration. So we use this KMnO4 to titrate with the mixture in the flask B. Okay, and we titrate until the end point. Okay, because we use KMnO4, so no indicators needed. So it will be from colorless to permanent pink. Because once the reactants, means the Fe2, finish reacts with the KMnO4, so the extra drops of KMnO4 will turn the solutions pink. So at the end point, we will see the permanent pink color. Okay, so this is all the steps and the working, right, for this question. Okay, so we might come back to these steps to discuss, right, if needed. Okay, for part A, after titration, so the student obtained a few values, titer values. Okay, so run rough and 3 accurate titration, and the student repeats the titration until the concordant readings achieved. So concordance means the readings when they reach to the difference same or less than 0.1 cm cube, then we can stop. So for example, titration 1 is 9.65 cm cube and titration 2 is 9.90 cm cube. So the difference between them is more than 0.1. So this one we cannot consider as the concordant titer. So after that, the third titration is 9.75. So the difference between the the titration 1 and titration 3 is 0.1. So therefore, we will take these two for the calculations later. So that's the meanings of concordance readings, right? So when the readings that we get, their difference is same or less than 0.1 cm cube, then we can stop the titration. Okay, so then we go to the next part. Okay, table already filled up, so just get the titer values, and okay, for part 2 we need to calculate. So show the calculation, take the two values, okay, that obtained, 9.65 and the 9.75. So just take these two for the mean titer, right? Because their difference is 0.1 cm cube, right? So it's more accurate to take these two for the calculation. So then we get 9.70 cm cube. Okay, part B. State what is means by standard solution in step 6. So there is a one term called standard solution. Okay, so here, rinse a burette and fill with standard solution of KMnO4. Means before titration, the burette need to rinse with a solution called standard solution. Okay, so what is this standard means? So this standard solution means the solutions with a known concentration. Just for example, like 0.01 mole per dm cube, 0.02 mole per dm cube. When we know the concentration of the solution, that we call standard solution. Okay, so for part C1, suggest why conical flask A is left for 4 hours in step 2. So for the 4 hours, okay, because it's a reaction between the iron 2 and the silver, and it will form the iron 3 and the silver particle. So therefore, after it reacts, okay, it will take times for this species to reach equilibrium. So the 4 hours is actually to let this reaction mixture, the reactants and products, to reach equilibrium. Equilibriums take times. Okay, part 2. Suggest why conical flask A is not shaken during the final hour in step 2. After the 4 hours, 1 hour we use to settle the solution, because in this reaction it will form the silver particle. Silver ion will form the silver particle, so it will reduce to silver particle. Then this one means the final hour we'll use to let this solid silver to settle. Okay, part D. Suggest why a measuring cylinder is the most appropriate apparatus to use for measuring sulfuric acid in the step 5. Okay, so if you still remember the step, after we add the sodium chloride, so we add the acid. So the H2SO4 that we add, we normally just use measuring cylinder. Okay, so why we use measuring cylinder and we don't really like use pipette or burette? Because it's not really necessary. Okay, the acid used is actually for the redox reaction. So as long as sufficient for the redox reaction, then it's okay. Its volume, it will not really affect the the titer value. Okay, and in this, of course, in this reaction, the acid is in excess. So when the acid is in excess, so the volume that we take is not really need to be so accurate. So no need to until 0.05 or 0.00. Okay, that's the meaning, because the acid is not really important to get the titer value, because as long as sufficient, then it's okay, right? So that's why acid is in excess, so we just need to use measureless cylinder. Part E, state what the burette should be rinsed with this in the step 6. Okay, so this one I already told you. To rinse the in step 6, let's get back to step 6. Okay, so rinse a burette and fill with the standard solution. Okay, if we want to fill with the standard solution of the KMnO4, then we must rinse the burette with the same solution to make sure the burette has no extra water or impurities, right? So it's better to rinse the burette with the same solution. So this one is quite easy. Okay, so therefore, so the KMnO4 solution itself, okay, is going to use to rinse the burette. Right. Okay, part F, state the change of color seen in the mixture in the conical flask B at the end point in step 6. Okay, I told you just now, right? So the color change will from colorless from the iron 2. Once iron 2 finish reacts, and the extra drops of KMnO4 will turn the solutions pink. So therefore, the color change will be colorless to pink or permanent pink. Okay, part G, the student repeats the experiment using KMnO4 at a lower concentration. When KMnO4 that used for the titration is lower concentration, it means that the volume that used is going to be larger, right? So therefore, the student obtains a larger mean titer value or titer volume. So suggest one reason why a larger titer is better than a smaller one. Okay, so then it's better to show the calculations to you, then you understand how. If let's say the volume now is smaller, let's say 9.7 cm3. If we want to calculate the percentage error, so we use the 2 times the accuracy or uncertainties over the volumes, this volume times 100. So we will get 1%. If we use a larger volume, let's say now volume double, so now it's 19.40. Okay, we do the same calculation. So 2 times 0.05 over 19.4 times 100%, we get 0.52%. So means when the titer is smaller, so it will actually give lower percentage error. So that's why it's better to have a larger titer than the smaller one, because lower percentage error. Part H, the equilibrium is shown. Okay, this is the reactions that we discussed just now. Okay, when another student carry out the titration with 0.02 mole per dm cube KMnO4, the mean titer is 21.10 cm3. Okay, now the ionic equation is given. From this equation, we know that the mole ratio of the permanganate ion to the iron 2 is 1 to 5. This is a mole ratio. So we use this ratio for calculations later. Okay, so part 1, calculate the concentration of Fe2 in the equilibrium mixture. Okay, so first we need to calculate the moles of the MnO4 negative. So from the titration we know that it's 21.1. So MV over 1000, concentration is 0.02 times the volume over 1000, we get this mole. The moles of the permanganates are 7 ion. So is this. Now the moles of iron 2 ion will be 5 times. So use this mole times 5, you get this. Concentration of Fe2, because we take 25 cm3 for titration. So therefore, it will be 25 here over 1000. So the mole that we calculate just now over this volume, so we get 0.0844 mole per dm cube. Okay, part 2. Suggest why it is not necessary to measure the concentration of silver ions in the equilibrium mixture experimentally. Okay, because the concentration that we use is actually the same concentration. Okay, let's get back to this. Because we add the same volume and the same concentration of these two ions, the silver ion and the iron 2 ions in there. So means when the iron 2 reacts and form the iron 3, so if you react with the same mole ratio with the this silver ion, so because their ratio is 1:1 ratio, how much is used, then the silver is going to use the same amount. Means at the end, the concentration of the silver ion and the iron 2 ion, it will be the same, right? So that's why it's not necessary. Okay, it will be the same concentration. Okay, therefore, part 2, the answer is what? Because it will be same as what we calculate just now, 0.0844 mole per dm cube, right? Same as this. Okay, part 3 determines the decrease in the concentration from the initial solution. Okay, after that, try to determine the concentration of Fe3 in the mixture, equilibrium mixture. This one, first you need to calculate initial concentration. Again, let's get back to the diagram just now, which is very useful for you to understand. Okay, because initially we add the two solution, which is 100 cm3 each with the same concentration. So when we mix these two solutions together, total volume is 200. And the concentration of these two ions, it will be half. Means the concentration now will be 0.1 each. So it will reduce by half because volume now is double. The concentration of the silver ion and this iron 2 ion will be halved, right? So all these two will become 0.1. Okay, therefore, this is the first thing you must calculate. Initial concentration of iron 2 ion will be 0.2 over 2 because volume is double, concentration halved, right? Okay, after that, use this concentration, the initial minus the concentration. So we will get 0.0156. Okay, so now we get the concentration of iron 3 at equilibrium, and we get the concentration of Fe2 at equilibrium, right? So we can substitute the value into the Cassidy expression. Okay, 0.0156 over 0.0844 squared. So we get 2.19. Okay, so you can get the units easily. Just do the units cancellation. So you get dm cube per mole. Right, that's all for this question. Thank you.